All right. Hello, everybody. Welcome in. All right. How's it going, everybody? I'm late today. I apologize. Just was really tired today after work. Had to take a little power nap. Just been struggling to fall asleep at night and a lot on my mind and the stream's been going late, so I've been just gathering up late hours and then all right. Mahan's got a what is it, like those sneaker bots that buy shoes really fast? That's Mahan for the stream. All right, we are live on Twitch. Hello, everybody. Welcome back in. I appreciate everybody for joining me today. Today is Tuesday, April 1st, 2025, and this is going to be, unfortunately, my last stream ever. I am quitting YouTube and I'm quitting coding. I This is kind of a shock. I know. I'm sorry, you guys. I put in a lot of time and hours into this, but I have decided to pursue other things and try something new. So I will no longer be doing daily study sessions of the stream and of the learning. So I apologize to you guys greatly for that. Um, Here we go. It's April Fools. April Fools. Got you guys. Got you guys. Got you guys. Ha ha ha. Oh. Car- Carlos, I got you. My bad. How's it going? I've been doing Twitter trolling all day. I'm familiar with your game. Kerwin, it's April 2nd for Kerwin. Mahan doesn't like April. I wasn't fooled. No fools. Okay, I got Carlos. All right, you guys. Fun little game we played. The title of the stream says I'm quitting coding slash YouTube. That's obviously April Fool's prank. The grind continues on. I'm just a little bit late today. Sorry, honestly. I'm human. I just had to take a little power nap after work, and I doing a late night streams and stuff is starting to add up on me, and I'm just getting more and more tired. So but I feel good right now. I recharged, got a reset. We are good. That's why I like to use the weekends to reset and charge my batteries. I usually like to try to take naps on the weekends, but we had to fit one in today. So, if sorry if I got you guys for April Fools. Leave some hearts in the chat. Leave a thumbs up if on the stream if you're part of the early crew here. Thank you guys truly for being here. You guys are awesome. Let's go ahead and I'm probably not going to stream too late tonight just because I am already late. I don't want to again set myself back. I'm trying to reset the sleep schedule back to something a little bit more appropriate. But we're going to hopefully I want to tackle 108 and 110 today. I want to take care of these two problems and finish them. Yeah, I get you, Carlos. Man, it's nice though to you know to feel the same as other people though, right, Carlos? We're in the same boat here, so we can be tired together, but we're gonna show up day after day, and we're going to put in the effort that's required. I was worried there was a nuke at work. What? Oh, that some didn't show up. No, I need to be better about giving you guys announcements too. I just get home sitting in traffic and then eat some food and then oh, chat's not working. My bad. Let me go ahead and load up. Oh no, All right, let's load up the chat here. Thank you for the reminder there. Sweet. Can we do 3 today? If we move quick, if you guys can help me out with these and we move fast, then we might be able to do more. But I'm at least planning on doing the, like I said, 108 and 110 today. One oh eight and 110 today. And 111, you say? Yeah, well, we just need to get through this tree section here. This tree section is so annoying. I can tell you this right now, though. This 121, I have attempted this one on, I don't know what it was, on maybe the leak code, but this one, I'm not looking forward to either. I struggle with this one. Right, Tim? Right. What you guys been working on? What have you guys been studying lately? What topics are you interested in? Let me know what has been recently been on the agenda for you guys. I'd love to hear about what you're working on. How is school going for you guys? Let me know what classes are working out for you. What's hard, what's not. Let me know all about that. All right, let's go ahead and get into this here. All right, let's read for a second here just to warm up, and then let's get into the elite codes. Okay, chapter 10 here. Still on chapter 10, this stupid freaking book. I think we have like 10 more pages left. Okay, so this was skip lists. Okay, here we go. We give a pseudocode description of the skip list search algorithm, skip search, in code fragment 10.12. Given this method, the map operation, map at key of index of k, the key is performed by computing p equals skip search of k, and testing whether or not that the key at that position is equal to k. If these two keys are equal, we return the associated value, otherwise we raise a key error. So for skip search, we input a key to search for. Position is the bottom list with the largest key such that the key at the position is less than or equal to this key here. So the position start, while below position does not equal to none, do p below p. So continually cycle down. And then next, you choose the next number while you're greater than to reduce down again. So scan drop down and scan forward. As it turns out, the expected running time of algorithm skip search on a skip list with n entries is O log n. We postpone the justification of this fact, however, until after we discuss the implementation of the update methods for skip lists. Navigation starting at the position identified by skip search k can be easily used to provide the additional forms of searches in the sorted map ADT, find GT, and find range. Insertion in a skip list. No, it's April Fool's, Tyrizian. Thanks for coming in. I just got my Georgia Tech. I just got in Georgia Tech for Master's Computer Science, dude. Congrats. How'd you get it? What did that take? That's super awesome, man. Like, what kind of prerequisites do you take? Let me know about that. Give me some info if you wouldn't mind. Do you have to be in person, or is it online, or? Mahan's playing games today. Mahan's gaming. Okay, insertion in skip list. The execution of the map operation map at key k equals value begins with a call to skip search of k. This gives us the position p of the bottom level with the largest key less than or equal to the key k. Note that the p may hold the special item with key negative infinity. If the key of the position equals to k, the associated value is overwritten with the value v. Otherwise, we need to create a new tower for the item's key value. We insert the key value immediately after position p within the S0, right? So you would search through the S0, find a position either less than or equal to the k value, and right, so if you don't have that key in there, you just be one step prior, so you could insert 1 plus. And then we insert, after inserting the new item at the bottom level, we use randomization to decide the height of the tower of this new item. Remember, because within these skip lists, you have these associated towers. So this is what's happening is let's say we're inserting the value of 40 into this skip list, right? Well, we would first start on our S0 index here of this sublist, this 2D matrix almost. We would iterate through and find the value of 39, right? Because going one forward would be equal to our value, but one forward in the list is 44, which is greater. So we would stop at 39. We would then insert at 1 greater, the space in between here, so the value of 40, and then we would flip a coin, usually 50-50, to determine if this then extends upwards, right? So this could, if it gets lucky enough, extend upward all the way to the top of this into S sub 4 if it hits, a 50-50 chance 1, 2, 3, and 4 times. So it'd be 50-50 times 4, or, whatever percentage that is. So it'd be like, what, 25% chance, a 12.25% chance, and then a, whatever it is, 6.125% chance of hitting up here. So here we go. After inserting the new item at the bottom level, we use randomization to decide the height of the tower for the new item. We flip a coin, and if the coin comes up tails, then we stop here. Else, the flip comes up heads. How about my tunes? I forgot they were gone. Yeah, did I get you, Marty? Did I get you? April Fools, we ain't quitting. Hey, Dev Vlad, how's it going, dude? Thanks for coming in. I appreciate you for joining me on Twitch. If you guys aren't know, we are live on Twitch as well as YouTube right now. So thanks for coming in, Dev Vlad. If you wouldn't mind, you can also find me on YouTube. We have just over 1,600 subscribers, and if you guys are here and new, thanks for joining me. My name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company since 2021 when I graduated, and I've been teaching myself how to code for about 8-9 months now, and we've come quite a long way. Mike, I got in MIT AI researcher position. Dude, nice. Everybody's been getting work lately. Did you recently hear the news about that, Mahan? A lot of people have been getting some internships, some jobs. We had a few people on the channel get jobs. Maybe I'll have to post a section in the Discord for people can post out their job successes. You can do either online or in person. I did online. Halfway through my engineering degree in software, getting through Python Crash Course book and doing Code Academy all at the same time. Carlos, you're going to be a beast, though. Think about that. Where are you getting your degree at, Carlos? Let me know. That's a lot of work, man. Where are you at in Python Crash Course? Oh, Mahan got April. Mahan, that's an April Fool's. I think he got us, Tim. I think he's trolling us. All right. I have a Discord link down below if you guys want access to all the resources from these notes to these books I'm using. So please join the Discord. There's a lot of great stuff in there for you guys to get access to for free. Okay, we flip a coin. If the flip comes up tails, then we stop here. Else, the flip comes up heads. We backtrack to the previous position, next higher level, and insert the key value in this level. We again flip a coin. If it comes up head, we go to the next higher level and repeat. Thus, we continue to insert the key value in the list until we finally get a flip that comes up tails. We link together all the references to the new item key value created in this process to create its tower. A coin flip can be simulated with Python's built-in pseudo-random number generator by randomly from the random module by calling a random range of 2, which executes either 0 or 1 with a probability of a half. We give the insertion algorithm for a skip list S in code fragment in 10.13 and illustrate in figure 10.12 the algorithm uses. We illustrate it in figure 10.12. The algorithm uses an insert after above function on PQKey value method that inserts a position storing the item key value after the position P on the same level as P and above position Q, returning the new position R and setting an internal reference so that the next, previous, above, and below methods will work correctly for P, Q, and R. The expected running time of the insertion algorithm on a skip list with entries is O log n, which we will show in section 10.4.2. So here is the skip insert key value. Insert the key and insert input k. Oh my god. Input key k and value v. Output topmost position for the item search in the skip list. P equals skip search index of we're going to search of k, right? So that's going to find the position of either one prior or the key if it exists. Q is equal to none. Will represent the top node in the new item's tower. The I is equal to -1. Repeat. I is equal to I plus 1. So this is, we're looping this. If I, right, this current index is greater than or equal to h, we're going to say h is h plus 1. Add a new level to the skip list. So add a new level to the skip list for height. We call next for the next value. Insertion in a skip list. Method coin flip returns heads or tails, each with a probability of 1/2. Yeah. Instance variables N, H, and S hold the numbers of entries and the height of the start in the skipped list. So exactly, so in this example here, the insertion of an entry with key 42 into the skip list of figure 10.10. So exactly like almost exactly the same example we used before. We assume that the random coin flips for the new entry came up heads 3 times in a row, followed by a tails. So we inserted 1, 2, 3 for those random coin flips to extend this tower upwards. The positions inserted to hold the new entry are drawn with thick lines, and the positions preceding them are flagged. Oh, because this is the new position next position. Removal in a skip list. Like the search and insertion algorithms, the removal algorithm for a skip list is quite simple. In fact, it is even easier than the insertion algorithm. That is, to perform the map operation delete at the map index k for the key, we begin by executing method skip search on the key. If the position P stores any entry with the key different from k, we raise a key error, right? So we do a skip search for the key. If the position restores any entry with the key different from k, we raise a key error. Otherwise, we remove the position from and all the positions above P. So we would remove this position with the 44 and all 44s above, which are easily accessed using the above operations to climb up the tower in this entry, starting at position P. While removing levels of the tower, we reestablish links between the horizontal numbers or neighbors of each position. So if we remove this 44, we need to link this 38 to this 55. The removal algorithm is illustrated in figure 10.13. and a detailed description of its left is left as an exercise in R 10.24. As we show in the next subsection, deletion operations in a skip list with n entries has O log n expected running time. Before we give this analysis, however, there are some minor improvements to the skip list data structure we would like to discuss. First, we do not actually need to store references to values at the levels of the skip list above the bottom level, right? So if you know the value at the bottom level, you actually don't need to store references of 17. You can just know that it's a branch of its main root here. In fact, we can more efficiently represent a tower as a single object storing a key value pair and maintaining j previous references and j next references if the tower reaches a level of s index of j. So, right, if you're at this 17, you would have a previous of 2 and a next of 3. So that's how you could track it, so you see how high it would go. We can perform insertions and removals in strictly a top-down forward fashion. We explore the details of this optimization in exercise C 1044. Neither of these optimizations improve the asymptotic performance of skip lists by more than a constant factor, but these improvements can nevertheless be meaningful in practice. In fact, experimental evidence suggests that optimized skip lists are faster in practice than AVL trees and other balanced search trees we have discussed in chapter 11. So in figure 10.3, removal of entry with a key of 25 from the skip list in figure 10.12. The positions visited after the search for the position of S index 0 holding the entries are highlighted. The positions removed are drawn with dashed lines. So we're removing the key 25 and reconnecting these nodes horizontally at these levels. Hey, Prax, what's going on, bro? Let's see here. Zane, welcome in, dude. I appreciate you joining me. How's it going, man? What's going on with you? If you guys are here, leave a thumbs up on the stream. Consider following along and subscribing if you guys are new. Thank you so much for being here. Mahan is almost not April Fool. Is Mahan the April Fool? Alex, we didn't finish. We solved one of the ones from yesterday. We stopped on one though. Yeah, this one seems pretty advanced. I haven't seen a lot of examples that skip lists are used, but it's definitely interesting to learn about. Prax, welcome in, dude. Awesome, dude. Thanks for coming in. All right. Why does my music keep turning off? Yeah, last stream ever, right, Mahan? Got some toilet paper with me here, I guess. It's like coming out of the bathroom. Okay, let's finish this section here, and then we'll be done with the reading for today. Maintaining the topmost level. A skip list S must maintain a reference to the start position. The topmost level, left position in S. The topmost left position in S as an instance variable and must have a policy for any insertion that wishes to continue inserting a new entry past the top level of S. There are two possible courses of action we can take, both of which have their merits. One possibility is to restrict the top level H to be kept at some fixed value that is a function of n, the number of entries currently in the map. Okay, so we need some way to, let's say that you have values that want to keep pushing above and above our current height value. So we need to dynamically have the height be a depiction of a function of n. The number of entries currently in the map from the analysis that we see is h equals map 10 to log of ceiling n is a reasonable choice. Picking h equals 3 log ceiling of n is even safer. Implementing this choice means that we must modify the insertion algorithm to stop inserting a new position once we reach the topmost level, unless floor log n is less than, the ceiling of log n is less than the ceiling of log n plus 1. In this case, we can now go at least one more level since the bound of the height is increasing. The other possibility is to let an insertion continue inserting a new position at it as long as heads keeps getting returned from the random number generator. This is the approach taken by algorithm skip insert in code fragment 10.13. As we show in the analysis of skip lists, the probability that an insertion will go to a level that is more than O log n is very low, so this design choice should also work. Either choice will still result in the expected O log n time to perform search, insertion, and removal, however, which we show in the next section. All right. What resources do you use again? Is there a way I can get a link to the PDF? Hey, Zane, thanks so much for coming in. Yeah, man, everything is in my description in the Discord down below. I have a really, really clean format for the Discord, providing you guys all the books that I read live on stream, my notes for those books, link to my GitHub, and then as well as weekly updates for courses I take and project showcases. So everything is in the Discord down there for you, Zane. Thanks for coming in. Hey, Outlaw, welcome back, dude. Awesome to hear from you. What's you been doing, dude? If you guys are here, leave a thumbs up on the stream, leave some hearts in chat if you wouldn't mind. It really helps to keep the engagement going and YouTube pushing our stuff. And follow along and subscribe if you guys are new. Thanks for joining me. Hey, Coach Mo, welcome in, dude. Awesome to hear from you again. How you doing? We're going to need everybody's help here on the leak codes today, so we're going to get started here in just a sec. We just finished the reading for today. So we are on 10.4.2. We have about chapter 10.5. Oh, finally. We have just about 5 more pages and then we're done with this stupid chapter. This chapter on hash maps has been freaking so long. Pause. But it's been a pretty hard chapter. Honestly, it's probably the hardest one so far, in my opinion. For those of you that have read this book, what do you guys think that your favorite, or what do you think what is your favorite chapter, and what is the most difficult chapter in your opinion? This is Data Structures and Algorithms in Python. I have 10 chapters worth of notes that we have so far. I started off in TXT and then moved on to Markdown, really giving you guys detailed notes. I highly suggest that you guys take a look at these. If you guys aren't planning on reading this book, you can just take a chapter a day and read over the notes to get kind of like a SparkNote overview of what is being taught about in this book. I'm going to get this online school done. I got 100 to 220 questions. Then I finished my senior year, dude. Nice. It's kind of anticlimactic, huh? You're like, wow, that's it? Like, I got a couple more questions and then I'm done? It's kind of crazy. It's a weird feeling. I was a pretty decent Rocket League player at one point. I coached some people in that field quite a long time ago, though I don't play video games much. Just kept the name. Gotcha. Rocket League's fun. I was never good at Rocket League. I used to do Fiverr coaching sessions on Fortnite. I made a decent from Fortnite. Wow, dude, that's cool. Frax is a Fortnite OG, God. If I had time, I would try to get back into it and charge, but... I'm definitely doing this book during the summer. I need to switch to Python for DSA. Java is not it for interviews. Gotcha. Yeah, this book has been, we've been going on this book since like November. It's just been little by little chipping away at it. We're on page 465 out of 770 here, so we're over halfway done with the book. And so, yeah, my goal is to try to finish before our 1-year programming mark. So by June, I want to have finished this book, and I want to have also finished Fluent Python as well, and then have been done with both of those books. Also be done with the CS50X. And then I want to start getting into some math courses for year 2. I want to start getting into some computer architecture, really leveling up. So who was it that was going into the master's program? Tarazian, if you're still in here, going through the master's program. Oh, he gave me this thing. Hold on. So he said you can do either. Preferred qualifications for admitted into the OMSCS students are undergraduate degree in computer science or related field, with a cumulative GPA of 3.0 or higher. Oh, gotcha. It's not bad. I graduated with a 3.8, so I've been looking into that. Should I document my progress if I do Georgia Tech Online Masters of Computer Science? It'd be a hard transition, me being non-CS though. Yeah, like the stream, you guys. Last stream ever for the April Fool. I haven't used Cursor IDE yet, Alex. I've just been using VS Code here. We got 17 people in here. Leave a thumbs up, leave some hearts in chat, and follow along if you guys are new. My name is Michael. I'm 26 years old. I've been teaching myself how to code for about 8-9 months now. We had just finished reading up some about DSA and Python that we do to warm up. We're going to now tackle some leak code problems and then get into this here. Yeah. So thank you guys for being here. Hold on one sec. Oh, we're good. Got you distracted. Yeah, that's what I'm a little bit worried about, honestly, is if I did the masters right, it'd be a pretty big transition into the math and everything. I like how you stream your sessions. I might start doing something similar in your future. 20 seems pretty fun. Yeah, coach. It definitely just adds an element of just accountability for me personally. You know, I have people here on viewers and friends and subscribers that, you know, enjoy watching my stuff daily. And so I have a accountability for them, but also to myself. I'm in college for CS and I take Calc 1 or 2, stats, linear algebra, Calc 3. Yeah, it gets pretty in there. Okay, we ready to do this one, guys? All right. Why does my music keep playing? Okay, let's get into this one. Okay, so given an integer, this is 108, convert sorted array. All right, everybody pull up 108 if you want to do this one. Given an integer array of numbers where the elements are sorted in ascending order or least to greatest, convert it to a height balanced tree. A height balanced tree is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. So in this case, the 0, this list of -10, -3, 0, 9, and 5, okay, so what's going on here is that every root position, if the number is less than, you assign it to its left root, right? So in this case here, what is going on? What is this? I don't get this part here. So why are we taking, so this is our example 1. Input, this numbers array. Outputs 0, -3, 9, -10, and 5. -10, 0. So what is this outputting? It's binary search tree. So we're taking in an array, -10, -3, 0, 5, and 9, and outputting 0, -3 is the left, 9 is the child, -10, or this is also accepted. So 0, -3 is the left child, 9 of the right child is 0, -10 of the left child of -3, null as the right child of or 0, -10 is also accepted. Right. Let's get caught up in some chats here. Distracted. I did my 4th leak code problem today, the placing flowers question. I don't know what, I'm not really sure what that one is. Which one is that, Distracted? Yeah, Mohan's been trying to get me to do linear algebra for a while now. Download David's A Course in Linear Algebra and start reading some. You start in it's in order of your list. You start with 0. If it's negative, you put in left subtree. -3 is greater than -10, so... Okay, so... We need to figure out what the root position would be, right? That's one of our first things we have to figure out is what would be our root. So right off the bat is if it's sorted, then you can divide this array in half, find the length of half of this numbers array, and that is going to be your root position, right, for each pass. So let's write a helper function here, def, we'll go def, create subtree, given a nums list of integers, right? So we're going to say the middle is equal to the length of numbers divided by 2, floored by 2. So let's say this is a length of, right, 0, 1, 2, 3, 4, length of 5. So this would be floored, would be length index of 2, so the 0. If it's length of 4, right, it'd be floored index of 2 here. So the middle is this. We would then say so if I have a middle index, right, this 0, I'm getting access to the middle index of this list, right? I want to create a root so we're going to go root is equal to nums middle, and we're going to create a tree node off of this, right? We're going to assign root dot placing flowers, question 605. Okay, I'll take a peek at that one. So we want to create a tree node of this root position. So middle equals to this. We're going to create a root, which is a tree node. The value, right, so the value, so tree node, where root dot value is equal to nums at middle, root dot right. This song always is a jump scare with that moan. I'll turn it up for you guys. Okay, so we're creating a root, which is a tree node. We then we assign the value equal to the numbers at this middle index. So then we create the node 0 here. No, I don't know about tree rotation, no. Why is it doing these? Why is it going to my iPhone? Okay. So I need to assign a slice. We need to assign a slice So we're getting in the middle index of the numbers list, which is this 0 value right here. We are then creating a root, a node using that value. Right. We are then going to assign its left pointer as the index to the left and its right pointer as the index to the right. So equals to nums index middle minus 1, or sorry, plus 1, and then root dot left is equal to nums index middle minus 1. Hey Wing Hong, dude. How's it going? Nice, Tim. Pause for real. So we assign the nodes. So we're creating a node off of that. So then what happens if we create a slice of negative 10 and negative 3? So then if we create a subtree on a slice, so then is this going to return root back to us? So then if we go like here and go so if middle equals 0, so the base case is going to be, so if middle none. So we return the root or we return none. So how do we want to create So we're getting the 0 here. We're creating a subtree, assigning the -3 to its left value. No, its root dot left is not going to be this, and root dot right is not going to be this. Its root dot left is going to be a create subtree recursive call to a slice of the numbers list of index up to middle, right? Or no, so of middle forward, right? And then the right root dot left is the self dot create subtree given the nums of index up to the middle. Right, so we'll recursively call this and create subtrees given. So then we'll say in here, we're going to call self.create subtree on nums provided. And then return this here. Two are given. Create subtree takes one position, but two are given. Nope. Okay, I outputted three. Huh. Interesting. I suggest you read about it. Maybe you don't need it for this question, but maybe take this class to see what you can do with trees. Okay. So we're returning create subtrees. So in this function, I'm going middle is equal to, in this first pass of numbers, right, is equal to index of what? Length of numbers floored by 2. So the length of numbers is 5, divided by 2 is 2.5, floored is 2. So 0, 1, 2. 0 is our middle index. So if middle is equal to so then we'll go like this, actually. We'll go n is equal to the length of nums, right? If n is less than 0, we're going to return none here, else we're going to take a middle of n here. So then we create a tree node for this right? So we found the length of the current recursion is greater than 0, so or greater than or equal to 0, so we can create a middle here. We're going to say so the length, if it's less than 1, if it's less than 1, not less than or equal to 0, if it's less than 1, we return none. Because if it has 0, then we know that there are no more nodes to slice from. So we create a middle index, right? We say we're going to make a root here, defining tree node. We assign the value of the root to the num's middle index. So the value will be 0 for this root. The right will be a recursive call to create subtree on, right, of the middle. So it'd be index 0 up through 5 through 9. So do I want to have this be middle plus 1? And this goes up to middle. So I'm not recounting the 0 anymore. My dog's being all funky. What are you doing? What are you doing? Object type int has no length. Oh. Oh, there we go. Woo! Look at that, boys. Solved it. Let's go. Not the fastest here. O of n. I didn't think I was going to solve it right there. That kind of took me by surprise. Look at that. All right. That is my solution. Oh, I think my dog farted, speaking of which. Something stinks. Yo, what is that? Oh, no. Hey, Sky. Come here. You went into the other room because you know you let it rip. What the heck? Come lay down. You let it rip and then you bail? You sick nasty. Just crop dusted me. You sick nasty? You sick nasty? All right. LeetCode can make you feel smart, but it usually just destroys my confidence. Yeah, I feel that, definitely. Throwback to when my dog dropped the nuke in the bathroom. Dude, I had one time in college where I came out in the morning and oh my god. Oh my god. Like, in my living room in college, in my apartment, it was like just like looking at landmines all over the ground. Just like I don't know how that much came out of her. It was crazy. Turn on the light? Oh, I forgot. That's why the vibe is off. Yeah, there we go. My bad. Got to get the lava lamp on. All right, we solved this one, you guys. I'm going to go ahead and take this solution. I'm going to say I solved LeetCode, what was this? 108. How does my solution look? Your solution is correct and follows a recursive approach in construction height balance BST from a sorted array. Here's a breakdown. You correctly find the middle element to act as a root and recursively build left and right subtrees. The recursion stops when n is less than 1, returning none, which correctly terminates the tree construction. You separate logic. Avoid slicing to reduce time complexity in spaces, which increases space complexity and, in the worst case, instead of using index-based recursion, avoid extra lists. So we could say middle is so we'd have to give a middle position. Right, we'd have to give a middle index. We would give numbers here. We would create, we would do this basically. So we would say that n is equal to the length of nums. We would then say well, hold on. We would, if we're going to use an index-based approach rather than slicing, we'd want to pass, we need to pass in the index, the middle index previously used back into the recursion to use again, right? So we have middle index here now. This is going to be length of nums divided by 2 for middle index. We say n is equal to middle index. So we pass in the length and so we pass in the initial length of numbers floored by 2. That'll give us the middle index of this 0 position, or 2. So then we say that n is equal to middle index. If n is less than 1, we don't need to take a middle then. We then provide, instead of slicing, we go up to nums well, we go like nums up to the middle index. Right, so up to, this would be n plus 1. And then this would just be n. Nums at n. Return root. So we need to provide okay, so we wouldn't want to slice. We provide the list, right? We then give the middle index of n here, which is the length of so the middle index. Shoot. Whatever. I don't really care. We solved it with slicing. Right. Hey, Ronnie, how's it going? Can you suggest some resources to learn DSA and Python? I'm a beginner. Yeah, Ronnie, check the discourses, the Discord, link down below. See ya, Tim. I'll see you tomorrow. No worries, man. Thanks for stopping in again. I'll see you tomorrow. If you guys are new here, thanks so much for joining me. I'm Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company. And I make biological controls. I make a lot of solutions of various serums, plasmas, blood, urine. Just this week, I made a 50-liter vat of urine that I've been having diffused for the next 3 or 4 days to crystallize and stuff like that. So I do a lot of biological-based formulation, and I've been teaching myself how to code in Python mainly for the past 8-9 months now through a lot of resources, and I have a Discord link below with a roadmap of all my stuff for free for you guys. So consider liking the stream if you're here, part of the late night crew, and then also subscribe and follow along. I stream every single day around 7 p.m. PST. So this is the approach with indexing. So okay, so you pass in the amount of values. Then you create a subtree given a left, right, and middle. Oh, okay. So you create a subtree which takes in a numbers list, a left pointer, a right pointer, and the amount of values. Then you say that the middle is left plus right divided by 2, right? If the left ever becomes greater than the right, return none, because you know that you're crossed over now. Similar to binary search using pointer. Okay, so you would go like this then. You would say that we also have to input in here the actual values, so the length of nums minus 1, so the actual number of values in here, right, which is going to be equal to a left and a right here. So the left is going to be 0, and the right is going to be the length of numbers minus 1, right? Because we're starting at the left, which is 0, and the total, the maximum index is the right. We're going to say if left ever becomes greater than right, return none. We're then going to create a middle, which is going to be left plus right. Okay. We're then going to pass in numbers left, right. So if we create a subtree to the left, I'm going to do the left one first. So if we're to assign the left subtree would be from 0 to middle. To create the right subtree would be from middle plus 1 to right. Right? No, it's middle, left, middle, minus 1. Sorry. This is left, because this is right over here, and this is middle, minus 1. So we don't need to evaluate middle again. And this returns root. So this should also work. Be a little faster. There you go. There's the most optimal solution. We were slicing, so it was slightly increasing our time. So we had to create those objects in memory. So this one's a little bit better using pointers and passing those in. All minutes are, I got you with the April Fools, my friend. I got a lot of people today. Oh, feeling good. April Fools, my friends. We're not quitting. We're dedicated to the grind. We are dedicated. I am too deep now, boys. We've been coding for a year of our life is spent on this, so we are in deep now. We can't quit now. A whole year of our life spent grinding this every day after work. So if I quit now, then it's a sunk cost. I can't do it. All right, let's go ahead and go back here. Problems. Balanced binary tree. Okay. Okay, so in this one, given a binary tree, determine if it's height balanced. Okay, so in this one that we worked on yesterday, thank you, Al Minotaur. I appreciate you guys being here. If you guys are new here, consider following along and subscribing. I really appreciate you guys being here. My name is Michael. I have a degree in human bio and a minor in chemistry. I work as a formulation chemist for a biotech company, and I'm teaching myself how to code every day after stream. A tear drops. No, Al Minotaur, I'll never leave you, my friend. We are in this together. Thank you for coming in, man. You're awesome. How you been? Okay, so we need to determine if this is true, right? Balanced or not. Height balanced. Of every node differs by 1. The height balanced binary tree is a binary tree in which the depth of the two subtrees of every node differs never by more than 1. The depth of two subtrees of every node. This has a depth of 0 for this subtree, whereas this subtree has a depth of 1. Whereas this subtree has a depth of 0, and this subtree has a depth of 1, 2. So this is not balanced. In general, this has a depth of 1. This root position has a depth of 1, 2, 3, so it's not balanced. So we're going to need to call a helper function again here. So is balanced So So I'm going to create a helper function called height, right, which takes in self and a root, right? I'm going to say balanced is equal to true. Then I say so what if I need to pass in height is equal to 0? So right, this will say if root dot left. So if root is none, return 0. Else we're going to say return left is equal to height of root dot left. And then we're going to have if root is none, return 0. So this is going to say return 0 back to us plus 1 for all the left nodes you can get. Right? So then we're going to say this. So it's going to be similar to the other one where we have a tuple for 1 plus height root dot right. And then we apply a max function to this and return the total is equal to this. And we're just gonna return the total. So this is gonna determine the height of every node, right? So if I'm on this node, if it has a left, it's gonna go down, down to the 0 case, return back up and go 1, 2, right, for a height of 2. So 1, 2. So that'll return the height of this node. So if we're saying, okay, we're calling is balanced on here, we need to determine the height of left dot right dot of this and this. So we'll call if root is none, return, we'll just say return 0. Right, else we're going to call height, so left height is equal to height on root dot left, and we'll do the same thing but for root dot right, for the right height. Right, and then we say if the absolute value of left height minus right height, right, is greater than 1, we're going to return false. Just gonna call here if root is none, return 0. It's a 0 height. Ooh. Oh. So I don't need to pass this in. got that one. True. This return null. Oh. So if the root is an empty list, dang it. Ah, we got another one, boys. Nerdwalk. We got another one on the April Fools. Thanks for stopping in, dude. I got you. April Fools, my friend. The grind never stops. You thought it was over? It's never over. It's never over. You can tell me what that movie is from? Extra channel points to you. You thought it was over? It's never over. What is that from? April Fools, New Rock. Okay. In this case, we're failing. 1, 2, 2, 3, null, null, 3, 4, null, null, 4. Yeah, West Coast. So it might be April 2nd for some of you guys still. So you guys are in the future. Then my fault. I didn't mean to give you the panic attack, but no. Not quitting, not quitting. Thank you guys so much for being here. We are grinding away. Okay, anyone know where we're going wrong with this in here? It's April 2nd, yeah, in New York City. For those, yeah, people, it's probably 12:20 right now, so the April Fool's joke doesn't work anymore for some people. So where are we going wrong with this one? So this is 1, this has 2 as the left and 2 as the right of the 1. This has 3 as the left of this 2, null as the right of this 2, null as the left of this 2, 3 as the right of this 2, 4 and null as the child of this 3. Can you draw this example? Yeah, let's try. Okay, so what I'm doing here is I'm given a node. Oh, this example. So we have 1, 2, 2, 3. The 3 is it goes null goes to this 2. This 2 gets null 3. Is it like that? 3 is null. It's null. 3. I'm not sure how to... If I add it to my test cases, will it do it? Yeah, we still output true here, except it should be getting false for this one. Hey, thanks for coming in. First time chatter on the Twitch. Booty sniffer. Whoa, booty sniffer. Coming in on Twitch. Thanks for coming in, booty sniffer. Appreciate you for coming in. Click the I. Oh. 1, 2. This is not balanced. Huh. Huh. What you guys think? If you guys are here, leave a thumbs up on the YouTube. We are streaming live to YouTube on Twitch as well. So if you guys are here, we are on YouTube too. We got 1.6. Let's see what subscriber count we're at. Thanks you guys for joining me. Truly, you guys are so awesome for being here. 1634 subs. Thank you guys for being here. Let's try to get to 1640. Appreciate you guys joining me. Yeah, this is our current solution so far, but we are not passing some edge cases. First child is 2 and 0. What are the plans after stream? Just chill? Watch some TV? YouTube Booty Sniffer is my name. Just Michael Deming on YouTube. Michael D. Deming. Michael D. Deming? I think it's Michael D. Deming on YouTube. Oh, sorry, Michael Dems. Michael Dems is my YouTube. Michael Dems. Some of these old streams are funny looking. You should put your Twitch category under software and game development. It would get bigger audience. Okay, let's do it. Let's see here. Put my Twitch under game development. How's the music too? Is the music too loud? Let me know if you'd like me to turn it down. Let's edit this. So you want me to put it under, what was it? You said under software and game development. Okay. Software and game development. There we go. One sec here. Let's fix the stream. Hold on, you could. All right. Anybody know how to allow you to do VODs on Twitch so people can go back and watch? How to enable VODs on Twitch. To enable VODs, follow these steps. Check your profile top right, select creator dashboard. Okay. Navigate to stream settings, settings stream. Okay. Enable VODs. Add a category. Oh, okay. There we go. Cool. That'll do that. Nice. Okay, we got that fixed. Cool. All right. Let me see here. Catch up on some chats. Just check Twitch stream on YouTube. Stream is in delay. Hey, it's me, Butt Sniffer. Hey, Ethical Hacking Noob. Thanks for coming in on YouTube. I'm a SOC analyst, got a CS degree, but work in the hacking side. Nice to meet you. Good to meet you too, dude. I have a degree in human biology and chemistry. I work as a formulation chemist, where I make a lot of biological controls and solutions and stuff. And so I appreciate you being here and joining me. Thanks so much for meeting you. Let me know more about your line of work. That seems really interesting. I've been teaching myself for about 8-9 months now. Hey, Riri. You need to make sure every subtree is good, not only the root. Refer to the definition of balanced tree. Okay. So then we need to do the verification within our height node. I like this song. I like this one. Oh, baby. Oh, my girl. I'm vibing right now. Tushar, how much of a delay is it? I know that the YouTube has a delay compared to the Twitch. The Twitch is pretty fast. Your code returns 1 for a single node. You plus 1 and go to none and return 0. It's height, not depth. Okay. So what do we have to? You shouldn't count edges, not. You should count edge, not node. Yeah, I think so. Hey, Tushar on Twitch. Thanks for coming in and chatting on Twitch too. You're awesome, dude. Max of 0 plus 1. So if the node is none, I'm returning 0 back. So should I return a -1 and then no, because I don't want to return -1 back. If it has a height of 0, this gives a 0 for that node. Yeah, that's what I was thinking. If we return -1, it'll account for it still, but it's still I think it's because, so we're evaluating the height of this root, but we need to evaluate the height at every root. So we need to call this function is balanced here. So we go like this. we say left, okay, we'll go like this. Left height is here. Right height is equal to this, right? We're going to do this here, like so. If the ABS is greater than, then return false. So we need to pass in basically, so if the root is none, return 0. This creates a height. We get the height at the, we check the validity of these heights at each node and return false. So the thing is we need to create like an indicator. We have to return the height and a Boolean. We need to return 2 values. Return true and a value of 0 with wrapped in a list, right? Left height is this call, which is on of index 1, right? Well, that's what we'll add it to. If this, we're going to set so we're going to return back to this function here a tuple, basically, almost, but you know, whatever, of true and the height currently. So if the absolute value is greater than 1, we need to set the value of left height and right height for this node to false. Then we call, if the root is none, we call, we just return Huh. So if the root is none, we're returning true and 0 for the height. So if the root is none, we return true for 0. Else we create a left height is equal to 1 plus height root left index 1. I thought I'm... Oh yeah, how's your MacBook been, Prax? How's that been going? So... I'm trying to access the first index, which is going to be this guy. But it's saying I'm accessing a bool. Huh. Hey, how's it going? I started following yesterday, man. I haven't even started learning Pi. Greetings from Argentina. You've got quite a reach. Thank you so much for those kind words, dude. Awesome, from Argentina. That's super awesome. What's it like is over there? Is it... Are the seasons flipped in Argentina? Like, is it fall time over there right now? Greatest thing I ever bought? Yeah, it's super nice. Well, how am I? I'm accessing index 1 of this list. Hey, DeVrit, I think we got another one, boys. We got another one on the April Fool's joke, DeVrit. My latest victim. Sorry, dude. Honestly, yeah. My previous height worked well. Oh. Hmm. So, what should we do here? Yeah, we got another one on the April Fool's joke, DeVrit. Sorry, my friend. We're gonna keep grinding here. So, what do I have to return? So I'll say this. Info is equal to true and 0. Return info. Alright, we'll go left height equals this returns this back plus 1. We then say if this is the case, so as balance function. You only had to call it recursively on left and right. Hey Chris, thanks for coming in on Twitch. I appreciate you coming in. Yeah, we can take a stab at that one. I might actually be calling it after this problem, but we can take a look at that one tomorrow. That one is, let's look at it. This is distribute money to maximum children. Yeah, we can take a stab at this one tomorrow. Thanks for coming in, dude. But yeah, we've been streaming for 1 hour 40 so far. For those that don't know, I have a 9-to-5 job as a chemist. I have a degree in human biology and a minor in chemistry. And so I do this after my 9-to-5 job every day. So just trying to teach myself. So I appreciate you guys being here. But yeah, we can totally take a stab at that one probably tomorrow, man. Thank you for coming in, Chris. Good to meet you. Let me know more about you. Recursively check subtree heights. Return false if any imbalance. So should I take it back to what I had before with just my height then, Oskov? So let's go back to my previous. Right, so this is what I had currently before. Right here. So this is what I currently had before, where we fail this case here. So I'm calling height on this node. I'm calling is balanced on this node as well. But what I need to do is I need to call self.is balanced on this height function. Right, to check if it's balanced at this height for whatever's returned here. But maybe not, I don't think so either. That probably won't work. Okay, so this is where we are here. We're getting the height of the node, and we are calling the height recursively on every node from the root position, right? But I need to call the is balanced. This gives me back a integer value. This gives me back an integer value, and this gives me back an integer value. I'm computing a difference. I return false. So do I need to oh, here. So let's just call if is balanced onto the root position here. Your current implementation is that Christ is a bully, sir? What? What are you talking about, Riri? That Christ is a bully, sir. What? Your current implementation is only checking your root. You want to check left and right before returning true. So you want to call is balanced on root.left and root.right as well. And so what I need to do that is do that to the root, right? So self.is balanced on the root. This will return I'm returning the height in this function. Don't touch the height function. Okay, let's leave the height function as is. So we needed to add a recursive call into this solution, into this balanced function somewhere for checking if the on every node value. Oh, the other guy on Twitch that gave you a problem. Oh, gotcha. Yeah, we're gonna check that one out tomorrow. So we need a recursive call on every node to check if it's balanced, right? Which will then subsequently call height on every node. Right, because is balanced calls height of left and right. So do I have to check is balanced on the root again? No. These are returning true. There we go. Let's freaking go! Woo! You stare at it long enough, boys, it'll come true. If you stare at it long enough, it'll happen. Sorry if I blew your guys' ears out. Let's go. So we need to recursively call on both nodes that we moved left and right on, but not on the heights. A Boolean expression return on both. It's just built different. Here we go. Woo! 2 hits here today. 2 leak codes today, boys. Leave a like for that one. I rarely do 2 leak codes in a day, so you got to leave a like for that one. All right, so what we're doing is we're determining the height of every node. Once we check that the height is past verification, we then need to call is balanced on the root left and root right to determine if those roots are also balanced. And so that'll cascade that forward, and so we can return a Boolean, and so if this is true and true, it'll return true. If this is true and false, it'll return false. So false will be the trumping factor. Which one was the first? Oh, here we go. We did 108. Yeah, we did 108. We're gonna have to call it here, boys. I'm gonna, one more! You guys are funny. You guys are hyping me up. I really appreciate you guys so much. So for those of you that are wondering about the Small Business Manager, so for those that are new here, I don't only do leak code, I build my own projects as well to solidify the learning that we're doing in both the DSA and Python reading that we're doing, as well as the Fluent Python that we're doing. So I know yesterday I told you guys I was going to meet with my dad, who is a CPA, to go over the income statement and balance sheet portions of our project. So this is currently what our project is. So I'll show you guys what is going on here. So I wrote this completely from scratch on my own. I didn't use AI to write any of this code. I did use AI to prompt when I had questions or when I was learning new things, but I didn't. All of this code is my own, live on stream here. So this is our current iteration of the program. This is called the Small Business Manager. I've created this UI in Python from scratch and designed it on my own here. I've also implemented all the front end and all the back end on my own here too. So the inventory, we have an inventory tab where we're able to load in inventory items by their date, description, size, and cost, right? If you try to add in duplicate items, it'll refresh. So let's go ahead and let's do 2025-04-01 description. Let's say that this is Prax, P-R-A-X-A-I-Z, P-R-X-A-I-Z. Right? Size is a medium. Cost, let's say this costs us $14.59.58, right? If I add this item, boom, there you see it was added to our inventory system via SQLite here. Now if I try to add this item one more time, boom, it refreshes, status failed, duplicate item, and refreshes our matrix showing us that duplicate item populated. So that's pretty cool. So right, that accounts for the duplications, and then we can refresh the matrix to bring it back to our original form. We can go here and to our search items, select a heading, a column heading to search for. So let's do a date purchased of 2025-04-01. The only item in there is this one that we added today, and search, boom, and that pulls that one and refreshes our matrix and pulls it right on up for us. So it's really cool there. We then have the expenses tab, which is something very, very similar, just takes in a little bit more criteria for actually adding an expense. You can't add duplicate expenses. You can't, but you can, continually add new expenses as such with a date, description, cost, category, method, and note, right? Now the note can be blank. That's the only thing, is that you don't have to give a note. Now then a couple days ago we worked on yesterday we worked on the transactions page. So we finished the transactions page. Right, the transactions page, where we are able to not only able to log transactions per individual inventory items, right? We're selling inventory items that are found in our inventory tab, but we have these linked via SQLite databases to have alternate keys to reference those items as well. So when we create a transaction, we provide an item ID to associate with the transaction. So the ID of this item, so item number 7 was sold, right, via its status. So if you go to transactions and search for a transaction via item ID of number 7, boom, there is that item ID number 7 associated with this item here, right? And as you can see, the status was also updated for this item as sold via the transaction that took place. So what I'll go ahead and do is I'll show you guys, I'll transact this item number 8 here. So let's go, date is 2025-04-01, item ID is number, let's first give it 9 to show you guys it not working for items that aren't found in the database. Item amount, let's say we sold this for 25 bucks. We sold it on Instagram. We shipping was $5, no fee, no discount, and we'll say this is a test sale. Right? So I'll go right in our inventory. You guys can see that Prax, his item right here for $14.58 is in inventory status. If I go ahead and commit this transaction for an item ID 9, boom, invalid, failed, invalid item ID number equals 9. So then we'll go ahead and update that appropriately for, now let's say I try to sell item number 7. I already sold that one, so if I try to commit this, failed, duplicate transaction, and it didn't do anything, right? Because I'll refresh and I'll try it again. I'll try to commit this transaction for item number 7, which was already sold here, right? Boom, it does that same type of fundamentals or functionality where it will refresh and populate and bring up that item to show you that that is a duplicate that's been already sold. And then, so we can refresh. And so let's go ahead and commit then item number 8 for sale, this Prax item that we transacted, that we added. So let's commit this, boom, there it is. Right? And as you can see, if we go over to the inventory tab without us having to ever even refresh the matrix, because I'm passing in the inventory tab as an argument or parameter to the transactions tab, so I can use its refresh functionality within the confines of the transactions tab. If I go here, you'll see that item number 8 was already transacted as sold based on that update. Boom, and there it is. Item number 8 is sold already and updated. We don't have to refresh the matrix on our own. It already does it as soon as we do it in this other tab. So it's linked together. So really, really cool. So now the next portion is, right, if we try to commit this same transaction, it'll load up. Boom, there is that item number 8, failed duplicate transaction, not allowed, right? And so we can then search for the item ID of number 8, right? And search, and there it is. There's our transaction that we made. So my next goal here is I wanted to this is just the ID of the individual transaction. So as you make transactions have IDs associated with them. So they'll constantly increase, up through time. Not super critical for recording the transactions, as you'll probably never really reference transaction IDs because you really care about the item ID that was transacted. But the ID is just of the transactions uniquely, and then the item ID is the reference to the inventory item ID provided, right? And so what's also cool about the transactions tab is that the transactions total column, similar how you would in Excel, I have it auto formulating for the item amount plus the transportation charge, so 25, less the fee, so 20, less the discount, so 15. And as you can see, I'm not ever inputting the actual transaction total into this commit transaction. It's auto generating and populating similar to how you would with Excel. Right? Yeah, so we could make that column, yeah. We could change it or something. It's just an ID of the transaction. So my goal then, what I need to do is, I unfortunately wasn't able to connect with my dad today because he is a caretaker for my grandpa, so he is pretty busy during the day and kind of helping him out and gets pretty wiped out. But my dad is a retired CPA, and I wanted to get his input on the actual fundamentals of the income statement and balance sheet, because when you start talking about income statement and balance sheet, you bring in this whole concept of double entry accounting, which is where you separate your inventory and your expenses separately, and then report them on a tertiary thing on like a balance sheet via the assets versus liabilities equals owner's equity or whatnot. So the income statement will be where we calculate the income for the business, so the amount of revenue less the amount of expenses for that associated revenue. So we'll do the amount of the sale total minus the cost of the individual item is that revenue. We'll have to, and then a couple more data points, but then we report that revenue as total assets or whatnot, or or there's, I'm not exactly sure. I can't remember. I was an accounting major my first year and a half of college, but I switched over to biology and chemistry. And so I can't remember exactly what goes on these. I just want to get his opinion on a solidified approach for what kind of information is reported on here. I'm thinking that what we can do is just create an overarching income statement class, right? And then what we can do is have it just house yearly information, and then we can populate a matrix across this whole tab that'll just be line items for the individual years selected. So that's kind of what I'm thinking. So you'll select 2025 via a drop-down menu, and then it'll populate some sort of chart via all of its income statement, calculations for 2025. And then, or you could do a drop down for 2024, and then it'll populate and refresh for 2024, and so on and so forth. And then something similar for the balance sheet. So we'll have some sort of indicator, to switch from yearly, or a month view or whatnot, or something like that. Maybe we could have like an overarching filter and then a sub filter for year or for month. And then we'll do the same for the balance sheet. Now the settings is where we're going to have the user have the ability to override individual business class settings. So we have this business class that's housing the expense categories, expense methods, sale platforms, and transportation methods. And so we want the user to be able to, and the name, to be able to come into this via JSON read and saves of this class information. We want the user to be able to come in and update the name, add additional categories, add additional methods, add additional platforms that tailor to the specifics of their business itself. And then it will automatically categorize and allow them to, let's say right here, right? If I go here and add in an additional test platform, right, as a dummy here, because I'm pulling this information from here on launch via my app Pi in this save and read business here. So if I go here, because what this is, the save is mimicking like me closing, and this read is mimicking me opening. So if I go ahead and run, you'll see that if I go to my expenses and I go to categories, transactions for sale platforms, you'll see that test platform will be in there now. Boom, there's the test platform. So it's reading that off of a file and uploading it, so we can actually now have the user upload in the settings menu their own custom platforms apart from Instagram or Depop, wherever they sell their inventory, whatever site it is, and also various methods for their transportation if they have different ones, categories for their expenses, methods for their expenses, and then also inventory sizing, right? So I could convert this sizing to a drop down and provide a sizing within here as well. So I currently don't have that anywhere actually. I wonder where I'm keeping that. Oh, I think it's in the check size function. So in my auxiliary functions, where are you? Here. In the check size, that's where I'm hard coding the sizes. So what I want to do is I want to import, I want to have the check size function be within this business class and save these sizes in here so that I can have the user custom update their sizes. That sound cool, guys? Oscar says, I always say it, but this is crazy progress. Like, no kidding, I've been a TA in unis and I've never seen this on Prog 1 or 2. What does Prog 1 or 2 mean, Oscar? For those of you that are in CS unis, what is Prog 1 or... Thank you so much, though, for the kind words. I'm really, really excited about this project. I put in a lot of mental work outside of stream just thinking about it. The whole design aspect of it, right? I've been thinking about this design for quite a while. When I first was doing the initial CLI environment of this program, I was like, this type of format would be really, really nice. And so I've had this idea in my head for months now as we were working on the previous version. And now that we've got it going, it's so cool to see it coming into actual, fruition here. But tomorrow when I meet with my dad, we're going to implement the income statement page. And then after that, the balance sheet, and then a couple of settings changes, options, and then the project will be done for a working, prototype to actually submit for our final project for CS50X 2025. So that's that's the plan here, guys. Let's ask for CS majors, what is Prog 1 or Prog 2 reference to? It's like programming 1 courses. Oh, okay. These are fundamental courses. So just like a beginner second semester programmer. Okay, gotcha. All right, you guys, thank you so much for joining me here. We streamed for over 2 hours and 5 minutes today. Please leave a like on the stream if you enjoyed the content today. We read out of DSA in Python. We read a couple of pages here on skip lists and how to insert and delete elements out of skip lists. We are almost done with the the chapter 10 here on hash maps and maps in general. This has been really dense for this learning so far. This is probably honestly the hardest chapter apart from trees. I'd say that this one is harder than trees in my opinion. It's been we've been on this chapter for like 3 weeks, just slowly chipping away at it. But we only have about 5 more pages, so hopefully tomorrow we'll be done with this chapter. Actually, tomorrow we're going to move on to Fluent Python chapter 3. So, right, because we're on chapter 3 now in Fluent Python, dictionaries and sets. So we're going to get right back into hash tables. Ugh, bruh. It never ends. Oh, whoops. Bumped my cord here. Hey, Shawnee, thanks for coming in, dude. I appreciate you for joining me. You're awesome on the Twitch. I stream on YouTube as well, so if you would like to watch me on there, feel free to look up Michael Dems on YouTube. I stream on there every single day. I stream every single day around 7 p.m. PST. I was a little late today just because I did take a power nap after work. So thank you guys so much for being here and joining me. My name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. I make biological controls that are used in patient diagnostics, like for diagnosing patients with diabetes, drug testing, pregnancy testing, and various other elements. I make like synthetic cerebral spinal fluid or urine bases or urine crystals to mimic kidney stones and whatnot. Kind of all these type of just synthetic mimics or imitations of diseases for patient diagnostics, which is pretty cool. And I've been teaching myself how to code for about 8-9 months now. I started June 2024, and we are coming up on our 1-year mark here soon. So I'm hopefully going to be getting through these books by our 1-year mark. That's my goal, is to finish Fluent Python and to finish DSA in Python by our 1-year mark, as well as finish CS50X and our final project here in Python. So right, this is our CS50X final project that we've written from scratch entirely in Python on our own using Tkinter. We spent about 2 days really learning Tkinter and grinding through, and now we've been able to open up the floodgates and use those tools to make custom business manager here for taking in inventory, expenses, and transactions via SQLite databases. And then we are referencing those transactions via the inventory numbers here. And then we're going to be working on the income statement and balance sheets next. So we also completed 2 leak code problems today. We did number 108 and 110 today. So super cool. 108 was convert sorted array to a binary search tree. So what we had to do was, this array was sorted, so we could infer that the middle integer or the middle index of this array would be the root, and then we can cascade it from there, making that less values go to the right, lesser values go to the left, greater values go to the right for each root node, and that's what we did here. And then we worked on 110, which was one partial that we left off on last time, where we had to not only find a balanced height from our root, but also implement a balancing across every single node. So I had to add in this additional check here for is a recursion call for the actual checking is balanced on the children of the main root itself. So it's pretty cool here. I really appreciate you guys joining me here. This was a lot of fun today. Thank you so much, Shawnee, for joining me on Twitch. Prax, Mahan, Oscav, you guys are awesome. Riri, thank you so much for the progress. Yeah, excellent progress. Thank you so much. Yeah. You're awesome, dude. I'm really grinding every single day. This was the April Fool's stream. I'm not quitting YouTube and coding every day. This was just an April Fool's joke. I appreciate you guys for having fun with me on that. And I'm sorry if I got you there and made you panic. But we're going to be back tomorrow, 7 p.m. PST. Happy April Fool's to you guys. Happy Tuesday, and see you guys tomorrow. Chat with me on the Discord linked below. Join my Discord and talk to me offline. Share with me your experience and your resources that you also are using in your learning journey, and recommend me anything you think that I would like as well that would be helpful to continue on learning. I really appreciate you guys being here. Thank you so much. I'll see you tomorrow, guys. Bye.